Okay, the whole point of this next couple of podcasts is to get you really, really familiar with your calculator. So let's get going here. Look at this. This one says solve by graphing. So you can use your calculator here because right now you don't know how to solve this using algebra. That's coming up in subsequent lessons. Okay, so solve by graphing the following equation. It is an equation because it has an equal sign. But the most important thing is it says to show the zeros. So in order to show the zeros, that in fact has to be 0. Right? So I'm going to rewrite this equation as 0 equals to x squared plus 3x minus 4. Okay? And now I'm going to bring up my calculator and I'm just going to plot that in here and let's see what happens. Okay, y equals to x squared plus 3x minus 4 is in there. I'm going to hit graph and ba-boom. Now I've got a nice parabola. Now look how this parabola is different than the one in the previous podcast. If you remember, the one in the previous podcast came down here and it did something like that and it touched once. And notice that it touches once. This is considered to have only one solution. And eventually you're going to find out that it actually has 2 solutions, but they're both the same. So that's why they refer to it as one solution. So we can say that this also has 2 equal solutions. That's kind of confusing right now, but you know what? Leave it to me. I'll get it to you in the next couple of podcasts and I'll show you why. All right, so let's erase this guy here. And if you look over here, what's really, really cool about this is this. Look how many solutions this has. It has one solution here and another solution here because, of course, by definition, you're looking at the points at which the graph cuts or touches the x-axis. That's what you're looking for. So this, in fact, has 2 solutions, here and here. Notice the other one had only one solution. But I got a question for you. What's the next possible kind? Or how many solutions can a parabola actually have? Think about it. It can have one solution. It can have 2 solutions. What's the next possible one it could have? Well, guess what? Think about it. How many solutions would that have? I ain't going to tell you. You got to keep watching podcasts. Now, okay, so how do you go about solving something like this? Solving it is very, very simple. Same old, same old. We go second and we hit calc, and of course, we're going to hit the 0 function. Now, notice here that you got 2 zeros that you got to find. Right? So you have to do this calculation twice. Again, there's the left-bound idea, right-bound idea. Notice how it's blinking right on this spot right here, right now. Well, you're not on the left bound. You have to go to the left, remember? Now, this just happens to mean that you go up the parabola. That's fine. If you hit enter, that shows you a nice little boundary there on the left-hand side of that point. Now, move over to the right. There we go. We're below the line. We're on the lower part of the parabola. And if we hit enter, boom, we notice that our bounds are set up properly. Left bound, right bound, around that point that we're most interested in. Then, notice it says guess. All you got to do is hit enter again. And it gives you a nice value here, the 0 being -4. So you can say one of your solutions is x equals to -4, which is really, really cool. Now, let's do this again. Second calc. Okay, let's find the 0 again, but now for the other side. So this is going to require you to do a little bit of mousing here. Okay, there it is. Now, left bound, you have to be below, right? Enter, there's a line that even shows that you're on the left side of the dot that you're interested in. Remember, you're interested in this dot right now. So you're on the left-hand side of it. Now, keep moving. Okay, hit enter again. Now you're on the right-hand side. Everything is set up, and of course, hit enter again. And look, your x equals to, in this case, x equals to 1. Now, what's really interesting here is notice that this y is always 0, so you don't include the y. It's like this y is 0 here, so you only give the x solutions. That's all it's after. It's not after a y solution, it's only after the x solution because y always equals to 0. So make sure you make habit of that because I know a lot of people like to say, oh, well, the coordinates of that are 1, 0. That's not what it's looking for. It's just looking for the x values, this value and this value. And you got -1, or I should say -4 and 1 as your 2 values. So let's go into this now. So we know the solution to this is x equals to 1 and x equals to -4. But I've got a nice graph here, and I actually want to show you how to graph this. And you have to be fairly accurate. Well, there's a couple things you have to remember. Number one to remember is this. What does this number mean? Do you remember from the previous unit what that number is? I'll give you a hint. It starts with y and rhymes with intercept. That's right, it's the y-intercept. And when does the y-intercept occur? Well, when your x's are zeros, right? Leaves you your y-intercept, so your x equals to 0. So now we can actually graph this particular equation much, much, much more accurately. Okay, so here we go. First things first, let's put in our values. X equals to 1 is right here. Boom. X equals to -4. 1, 2, 3, 4. There we go. So we got a point here and we have a point here. But not only that, we have that y-intercept as well at -4. So we can actually, I'm going to extend this down here a little bit, go to 1, 2, 3, 4. We have another dot right here. So we know our graph is going to do something like this. But I want to show you something. I want to show you something which is really, really, really cool. Count for me. Watch. 1, 2, 3, 4, 5. So you're 5. And remember, this thing is symmetrical. What does that mean? Well, if you cut 5 in half, you get 2.5. Watch again. 1, 2.5. Right? Watch from here. 1, 2.5. Guess what's way down here somewhere? That's right. That's where the vertex is going to be, somewhere down here. The only problem is we don't know what the vertex is. So I got a question for you. What is this value right here? If you look at it, that's 1.5. That's -1.5. Guess what? That is your x-coordinate of your vertex. Holy smokes, that's amazing how that works. Now, my question is, what is the y value then? Well, simple. You've got the x value, okay? Now you can find the y value, no problem. How? Bring up your calculator. X value is at -1.5. Go second, calc, find the value, which is the first thing. And it asks you, what are you looking for? I'm looking for -1.5. Hit enter, and look at that. It's at -6.25. That is your value. So go back to here. So you're looking at -6.25. So 1, 2, 3, 4, 5, 6.25. There's 7. So 0.25. I was pretty close. It's right around there. Now look what you have. You have a coordinate here, you have a coordinate here, you have a coordinate here, and a vertex that you found just by knowing that this thing is symmetrical. And look how accurate you can draw a diagram now. Look at this. There's your vertex. It goes right through this point, right through that. I would really say that you've drawn an accurate diagram, not just a sketch anymore. Whereas before, opens up, opens down, opens wide, opens narrow, blah, 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 blah. Now you've got a really accurate diagram because you know that's -6.25. You know that this is +1. This is -4. That you determined from the equation to be -4. Look how much more accurate your diagram is. Okay, one big note to put right here. So if the graph cuts the x-axis at 2 points, you have 2 roots. Stay tuned. We got more coming at you.